Good morning, statistics students. Okay, I'm going to make a brief video about how to solve a typical Chapter 6 problem. I'm looking at problem 26 in your most recent homework assignment. A publisher wants to estimate the mean length of time in minutes all adults spend reading newspapers. To determine this estimate, the publisher takes a random sample of 15 people and obtains the results below. From past studies, the publisher assumes that the population standard deviation sigma is 2.1 minutes and that the population of times is normally distributed. So if we know that we know the population standard deviation, which means we're justified in using the standard normal distribution. So this is how we would solve this problem. Okay, Mathematica is right here. Okay, Mathematica is right here. Let me download this file. Okay. And my directory, okay, by default, my directory is users Douglas. I need to change that. Set directory users Douglas downloads, because that's where the file is located on my computer. Okay, file names. Okay, so here's the file that I just downloaded, and I'd like to rename it so that it has a name that I can more easily remember. So we're going to call that, let's see, rename file, data for April 2nd, 2020, 11:18 a.m. .xlsx, and we're going to change that to problem 26.xlsx. So now if I use file names, okay, I see that I changed the name of the problem to problem 26.xlsx, which is right over here. It's right here. Okay, so now I just need to go through the usual procedure. Okay, so as usual, we're going to import the data, and I like to call it my data. Import problem 26.xlsx data, and then let's flatten that so that we have one list instead of nested lists. Okay, so now the mean is, let's see, my data, and that's going to be 8.8. It says here construct 90% and 99% confidence intervals for the population mean. Which interval is wider? Well, we know it's going to be the 99% confidence interval. If convenient, use technology to construct the confidence intervals. Okay. We already know sigma because it's given to us in the problem. I know that sigma is 2.1. Sigma is 2.1. And then we just follow the formula. So, well, actually, there's one more step before we follow the formula. I need the z-scores. So we actually need two sets of z-scores. We need one for the 90% confidence interval and one for the 99% confidence interval. For the 90% confidence interval, I need the two z-scores between which there's 90% of the area under the curve. So that means I have 5% to the left and 5% to the right, because 5 and 5 is 10, and 90% plus 10% is 100%. So really, I'm going to have to use, well, for this one, when it says 90%, when I give the command to Mathematica, I'm going to have to change that to 95%. So z is equal to inverse CDF, normal distribution, 0, 1, 0.95. Okay, 0.95. Actually, let me call that z, I'm going to call that z90. Z90. And then for Z99, so I'm looking for the two z-scores. So actually what this says, by the way, is 90% of the area under the curve is between negative 1.64 and positive 1.64. This one is different. I'm looking for the two z-scores between which there's 99% of the area under the curve. So that means I have 0.5% to the left and 0.5% to the right. So this is going to be inverse CDF, normal distribution, 0, 1, 0.995. Okay, so now I have my two z-scores, okay? So now I just have to create my intervals. So it's going to be confidence interval 90 is equal to mu minus z90 times sigma divided by the square root of n, and n is the length of my list. Like, how many scores do I actually have? So the length of my data is 15, so I'm dividing by the square root of 15, and then mu plus z90 times sigma divided by the square root of 15, and that's going to be my confidence interval, my 90% confidence interval. Well, I called it confident. I meant to call it confidence, but it's the same. It's really the same thing. Okay. The 90% confidence interval is 7.9 to 9.7. Okay, Pearson accepts my answer, and the 99% confidence interval is going to be, okay, confidence interval 99 is equal to mu minus z99 times sigma divided by the square root of 15, mu plus z99 times sigma divided by the square root of 15. And I believe everything looks good. Okay. And the 99% confidence interval is going to be, I am 99% confident or 99% sure that the real mean is between 7.40, oh, one decimal, it just wants one decimal place, and 10.2. And this is always going to be the case. The 99% confidence interval has to be bigger or wider. It's going to be wider than the 90% confidence interval, okay? Okay, so the hardest part of this problem is understanding how to convert what Pearson is saying here into a Mathematica problem. If you have a 90% confidence interval, okay, you have 10% left. So that's 5% on the left, 5% on the right. So you add 5% to 90%, and that's 95%, which is this number right over here. If you have a 99% confidence interval, then you have 1% left, which means you have half of 1% on the left and half of 1% on the right. So you're going to have to add that to the 99%. So instead of 0.99, I really have 0.995, which is this number right over here. Okay? Maybe that's the most challenging part of the problem. Other than that, you just basically follow the formulas and you really shouldn't have a problem. This is a very typical Chapter 6 problem, okay? I think that's going to be enough for now. I will post other videos for other problems in the future. I'll try to make 2 of these a week until the semester is over, okay? I hope the video was helpful to you. Have a good day.